All right, so let's just start at the start. We're going to go right back to the beginning of the unit. Let's take a quick second and even just remind ourselves about the ins and outs and roundabouts of the XY plane. Click all Chromebooks all the way closed. Focus up here. So where would I locate the point with coordinates negative 1, 5? Quadrant 2. Okay, now where would I go to do that? I'm going to go left. How far?
1.
And? Up 5. There you go. So I end up in that location. That is quadrant 2. Good. And the reason it's quadrant 2 is because we number the quadrants starting at 1 on the upper right, and then we just go counterclockwise. Yep, there we go. Perfect. Okay, so what about something like this? If we're asked to determine whether or not, oops. Ooh, I kind of gave it away, didn't I? Whoop. Darn it. Okay, so how do we do this? If I want to determine if the ordered pair negative 2, 16 is a solution of the equation y equals 3x plus 2, Vance, what do I do?
You insert the x in the y. So
Okay,
like
there you
16 would go at y, negative 2 would insert that.
There you go, exactly. So all I'm going to do is plug those values in, and if they satisfy the equation, if they make it true, then it's a solution, right? So the top one, if I plug those in, we would get y would become 16, and the x would become negative 2. And is that true? Is 16 equal to 3 times negative 2 plus 2?
No.
No, it is not. Thank you. It is not. That is false. So the answer is no. Exactly. Okay, see how that works? If it had made a true statement, then it would have been a solution, right? Okay, good. Determine the domain and the range of the relation. So on the test, you could have a variety of different types of questions that would all essentially be the same. Could be one like this where you get a set of ordered pairs. It could be a table with x and y values. It could be a mapping where you use the arrows. In any of those cases, what is the domain? Okay, domain's the x's, right? So somebody tell me, raise hands here. Somebody tell me, what's the domain? What are the values? Yes, sir.
7, 18, 39, 7. Oh,
Okay.
you don't have to do 7 times.
Good, we don't do 7 twice. We only do the 7 once. We don't repeat values. So it would be the 4 different values of x, which are those values. Okay, tell me with your fingers, everybody, how many, what's the range, the values of y? So how many different numbers would there be that would I include? 3 is correct. There's only, because look, there's only 3 different y values. 2, negative 1, and 6 are the only different y values. So those are the only ones I would list in my range. Okay, good? Because what they're asking for, they're not asking for repeated values. They just want to know what are all the different x values that show up in my relation, and what are all the possible different y values that show up in my relation, right? Give me thumbs. Is it a function? No, it is not. Good. I see lots of thumbs down. What's the problem here? Yes. Good. We get 7 shows up twice in the domain. So that means that the input 7 maps to 2 different outputs, 2 and 6, right? And that can't happen. The only rule for a relation to be a function is that each input has to have exactly 1 output. Exactly. And that's not true here. So this is not a function. All right, find the domain and the range of the graph of the relation. Okay, well, the domain you already told me is the x values. So what is the domain of that graph? What's it going to be? Show me with hands here. What do you think? Wants to help me out with this? Peyton, what's the domain going to be? If we look at that graph, what's the domain going to be? Going to go from what smallest x value to what biggest x value? Look at that graph. What's the smallest x value? The x is the horizontal variable, so the smallest x value would be furthest left. What do you get, Ash?
Could be greater than -3, less than 3.
Okay, would we include -3 and 3? We would, right? Because you can see that there actually are, if an ant was walking on this function, the furthest the ant could go left would be when he hits those left edges, right? And if I just kind of draw a vertical line to see what x value that is, that's -3, right? Furthest right the ant could get would be over here at +3. And so those would be the extremes, and then the ant could walk anywhere in between, right? So then answer would be A, B, C, or D for domain. Would be C, wouldn't it? Yeah. Okay, give me thumbs. Is that working? How about the range? All reals, yeah. Right? How come? Because the graph just goes forever up and down, doesn't it? Yep. Okay. Give me thumbs, everybody. Is this function?
No.
Not a function. How can we tell? What test does it fail?
Vertical line.
Vertical line test, yeah. Right? Vertical line test, remember, all that says is a relation is not a function if a vertical line if I can draw any vertical line that intersects it in more than one place. And this one intersects it in multiple places, and so now it fails. It fails the vertical line test, and so it is not a function. Okay. When we are evaluating functions, we've been doing this all year. This is no big deal. What do I do if I'm given f of x and they want me to calculate f of -5? Okay. From now on, let's raise hands. Don't say stuff out loud. I want to give everybody a chance to answer here. So I'm substituting it in, but let's follow. What do I have to be very careful about when I substitute? Yeah, I need parentheses, don't I? Right, I got to put it in parentheses, so I've got to do this. Okay, now where do we go from there? So this is just order of operation stuff, PEMDAS stuff. If you're still having some issues with this, if you're still a little rusty on this, because this is like, first quarter Algebra 1 stuff. If you're still rusty on that, you got to get on top of it right away, because this going forward, that is going to cause you lots of problems. If you have questions on that stuff, come see me. But if we follow PEMDAS, what do we have to do first when we simplify this? What's it going to be? The parentheses, sure. Inside the parentheses, there's really nothing to do. -5, I can't do anything with. So then what would be next? Exponents, there you go. So the very first thing we have to do, number 1, is I have to take care of that exponent. What do you think people sometimes, if you had to make a guess, and trust me, I've graded 1,000 of these problems, what do you think the most common mistake is? What do people sometimes do instead of exponents first? What do you think?
Multiply 2 times.
Yeah, they multiply 2 times -5 first and then square it, but that's not the way it goes. That's not until step number 2. You got to do the exponent first, then you multiply. And -5 squared, does everybody agree that's positive 25? If you plug in -5 squared on your calculator, you might get the answer -25. How come?
It's not in parentheses.
You didn't put it in parentheses. But even if you did that, if you typed in -5 squared and you saw -25, would you write down -25? No, because you know that any negative number squared is always positive, no matter what, right? Okay, so you'd even know, even if you typed it in wrong, you'd still think, oh, okay, that has to be positive 25, right? Because we always know a negative number squared is positive. So the next step would be multiplication, right? We'd multiply the 2 times the 25, which gives us 50. And then the very last thing we would do would just be subtraction, right? So I guess we got step 2. Oh. Step 2 is multiplication. Step 3, finally, is our subtraction. And 50 minus 8 is 42. And we got it. Okay? If you're ever unsure about PEMDAS, write down the PEMDAS tree, right? And remember, the M and the D are on the same rows, same as the A and the S. Okay. Use the graph of the function to write the corresponding ordered pair if f of 2 equals 3. Okay, first of all, we don't even need the graph. The graph is irrelevant. That's all the information we need right there. So what is, in this expression up here, f of 2, in this equation, f of 2 equals 3, what's the input number? Is it 2 or 3? 2. How do we know it's 2? Because that's the number we're inputting into the function, right? So the 2 is the input. So then what's the output? 3. Okay, so let's remind ourselves a couple things here. So we know that's always the case with a function. We're inputting, like f of x means we're inputting x values into our function. Whatever we get out of that's going to be the output. In an ordered pair, if we write something as an ordered pair, x, y, which is the input variable? Same variable, it's x, isn't it, right? X is what we input into f of x. X is the input in our ordered pair. So that makes y the output. Okay? So then if we see the expression f of 2 equals 3, and we want to write that as an ordered pair, we just have to write the ordered pair as input comma output, right? That's what x comma y means, input comma output. So what's the input number again? You already told me. 2. 3 is the output. So that's got to be the ordered pair then, the ordered pair 2, 3. Okay? I don't even need the graph. I mean, I can see it on the graph if I want to, but I don't need it. Over 2 and up 3. There's the point. You can check yourself by looking at the graph just to verify you got the right ordered pair, but you don't really need it. Okay, give me thumbs. How we doing? Good? Okay. All right, what about one like this? If I give you a function, again, this is or not necessarily a function, I'm giving you a relation that's a set of 3 ordered pairs, and they tell you to find f of 7. Okay, first of all, are you finding the input or the output here?
Output.
You're finding the output. What is the input?
7.
7, yeah, 7's the input. And you're using that to find the output, right? Okay, well, which one of those ordered pairs has 7 as an input, the first, second, or third?
First one.
Yeah, right there. What's that telling us? That's telling us that f of 7 equals 3, isn't it? 3 is the output. Okay? All right, use the graph of the function to find all values of x such that f of x equals 5. Okay, so now first of all, we want to find the values of x. Is that the input or the output?
X is input.
Input. So we're finding all the values of the input, x, such that f of x equals 5. Is 5 the input or the output then? That's the output, right? So that's the y coordinate. And isn't f of x is just a fancy name for what variable? F of x is a fancy name for y, right? And we always said that. So this is the same thing as saying y equals 5. So I'm just trying to find the places on my graph where y is equal to 5. How many places do you see where that's true? 2, yeah. And a really easy way to find them would be to just graph the horizontal line y equals 5. So I'm right on that. Every place on that line is where y is 5, right? Just find the places on the blue curve that intersect that red line then. And you can just do it, you don't have to actually write the line down. You could just do it with your imagination. But you know that the places would have to be, let's see, right there and right there. Okay, what are the coordinates of that first point? Yeah, 0, 5, but really 0 is what I want. They wanted the x coordinates, right? So one x coordinate where y is equal to 5 is 0. What's the other x coordinate where y equals 5? 2.
How come you wouldn't do your line further down?
The red line?
Yeah. Because the y is 5.
Because I want y to equal 5, right? So this red line, let me write that on my notes. The reason it's there is because we want y to equal 5.
So you want y to equal whatever the x equals?
We want y, well, it tells us right here, this just says y equals 5. F of x, we want to know to find all the x's so that f of x is 5, right? Okay. Okay, good question. Any other questions on that? Okay. So again, our answers were just 0 and 2 then. Okay. Just evaluating a function here, right? So the function v of x equals x cubed is used to find the volume of a cube with side length x, right? Find the volume of a cube whose side length is 12 centimeters. Well, we're just picking a value of x then, aren't we? We're letting the side length x be 12 centimeters, and I'm just plugging that into my function. Isn't that all I'm doing? Hey.
These are from leadership.
Okay. Oh, okay, I'll pass those out. Oh, nice. Okay. So I plug that in, type it in my calculator, and I get 1728 as my output. So the output is volume, right? Why is the output volume? Because that's the function we had. It's a volume function. Volume is my output, x is my input. Okay? Make sense? Just that easy. Okay? All right, so on to the linear equation stuff. They want us to do a bunch of things here. Rewrite the equation 5x plus y plus 3 equals 0 in slope-intercept form. So what is slope-intercept form?
Y equals mx plus b.
Y equals mx plus b. How do we know? Because it's named after its ingredients, slope and y-intercept, slope-intercept. Okay, so if I'm ever putting a linear equation into slope-intercept form, what am I doing? I mean, what really am I doing? I'm just isolating what? Yeah, just isolating y and simplifying. That's it. That's how we put a linear equation into slope-intercept form, is isolate y and simplify. So there's not much I have to do here. What are the only things I have to do to get y by itself on the left side?
Subtract 5x and subtract 3.
There you go. Subtract 5x and 3 from both sides, which just gives me the answer, y equals negative 5x minus 3. Okay? So there's the slope-intercept form of the equation. What's my y-intercept? Negative 3. How come? Because that's b, right? That's the meaning of b in slope-intercept. So the y-intercept is negative 3. What's the slope? Negative.
Negative 5.
Okay, negative 5. Good. So now when we want to graph any line, really all that takes is 2 points, right? 2 points defines the line, and then I just connect and extend. Well, whenever I'm graphing an equation in slope-intercept form, I start with the point that I already know, which is what point? Negative 3, right? On the y-axis, it's the y-intercept. So I've got 1 point right away is negative 3, right there. Okay, I want to get a second point using the slope triangle, right? Start with the y-intercept, use a slope triangle to get a second point. Okay, so now if I write my slope, you already told me, is negative 5. If I write that as a fraction, what is that? Negative 5 over positive 1, right? The negative, if a fraction's negative, it always goes in the numerator. Okay, so, whoops, so we get, as a fraction, negative 5 over positive 1. Let's remind ourselves about slope here for a second. Sometimes people get mixed up making these slope triangles. The mistake that I sometimes see from people is they make their run backwards. Never. The run always goes to the right. The rise could be positive or negative. A positive rise means you're going up, right? Vertically up. A negative rise means you're going down. The run is always positive. The denominator is never negative. So the run is always going to be an arrow to the right every time. There will be no circumstance where it'll ever be the other way. It's always to the right. So then what is this telling me to do? My slope triangle does what?
Over 1 up 5.
Okay, right. And I would get in the habit of always doing the rise first. So you're always going to make the vertical arrow first. Just do it the same every time. So we're rising by negative 5. 1, 2, 3, 4, 5. And we're running by positive 1 to get our second point. And then all you have to do is connect and extend, which the graphing tool does for you anyway, right? You just have to enter the 2 points. Okay? Give me thumbs. That makes sense? All of those are the same. All right, so a quick review of slope. A line has a slope of negative 8/9. If that's true, I want to find the slope of a parallel line. Well, what's the relationship between the slopes of parallel lines? They're the same. Parallel lines have equal slopes, and so the slope of a parallel line is exactly what I started with. They're the same. Okay, what about the perpendicular line? What's the relationship between the slopes of perpendicular lines? Opposite and not inverse. Reciprocal. Hey, what's up, Maddie? I will. Okay, you bet. Okay, you bet. Bye. For some reason, check your email before class is over, Haley. I don't know why, but so don't forget. Okay, so yeah, perpendicular lines have slopes that are opposite reciprocals. And so what does that mean? Everybody do this with your hands. We're going to switch the sign, flip the fraction, right? You got to do two things. So then what do we end up with? If our line has a slope of negative 8/9, a perpendicular line would have a slope of positive 9/8. There you go. Perfect. Okay. If we want to determine whether two lines are parallel, what's the only thing we need to know? Well, what do you mean by that? What's the only part of the line that we care about? Slope. That's it, right? Okay, what's the slope of the top line? Because it's in slope-intercept form, right? What's the slope of the bottom line? Okay, and this was an easy one because both the lines were written in slope-intercept form, but if they weren't, all I'd have to do is put them into slope-intercept form first, right? So let's just go through the list. Are these parallel? No, because those aren't equal. Are they perpendicular? No, it's tricky. They're not. They're reciprocals, but they're not opposites. Yeah, so the answer is neither. Okay. Okay, let's practice writing equations of horizontal and vertical lines. They're the easiest kinds of lines, but they're the ones that people mix up the most commonly, I think. Right, so we automatically know if it's a horizontal or a vertical line, those are the ones that are just either x or y equals a number. They're the easiest kinds of equations, but which one goes with which? To find out, just ask yourself the question, which axis does it intersect? A horizontal line cuts through which axis? The y-axis. So therefore, if it cuts through the y-axis, the equation is going to be y equals something. Y equals what in this case? 7. How come? Because that's the y-coordinate of every point, including the y-intercept. All I have to do is look at the y-intercept, right? Okay, so the answer is y equals 7. Okay, make sense? So again, if it's horizontal or vertical, just ask yourself, which axis does it cut through? And then whatever variable that is, that equals a number, okay? Hey, what about one like this? They give us an equation, 2x minus 4y equals 8. What form is that equation in? Standard form, yep. ax plus by equals c, good. So now they want us to find the x and y intercepts and then use those to sketch the graph. Okay, so how do we find x-intercepts? Raise hands. What do we do to find x-intercepts? What do you think here? I need some new participants here. Somebody who hasn't volunteered yet today. Help me out. Kennedy, do you remember how to find x-intercepts? Okay, I'll give you a hint. X-intercepts occur on the x-axis, right? What's the y-coordinate of every point on the x-axis? 0. There's the first. So what do you think I'm going to do then? To find x-intercepts, I set y equal to 0. Yeah. To find the x-intercept, set y equal to 0, and then just solve for x. When I set y equal to 0, whatever I get when I solve for x is the x-intercept. This is that cover-up trick I showed you guys, right? So if y is 0, in my original equation, what's 4 times 0?
0.
Yeah, so that term, I can just cover up the 4y term. It's going to go to 0. I'm left with the basic equation, 2x equals 8. Solve for x. What do you get?
X equals 4.
4. You got it, right? Okay, well then same logic. To find a y-intercept, what are my 2 steps going to be? What do I do first? Well, but what do I, not first. What am I going to do first? Coulter, what do I do first here? To find the y-intercept. To find the x-intercept, we set y equal to 0 and solve for x. To find the y-intercept, what do you think we're going to do? So, what do you think? Avery, you got an idea? Yeah, that's all I'm going to do. I'm going to do kind of the opposite. I'm going to set x equal to 0, and then whatever equation I get, I solve for y, right? So again, we can do that with just that little cover-up trick. If I'm setting x equal to 0, that first term just disappears. It's going to become 0, and I get a simple equation, negative 4y equals 8. Solve that, everybody. What do I get? Negative 2. Yep, negative 2. Okay. And now all I would have to do, I've got my 2 points, just use those to graph the line. I just need 2 points, right? So I've got my x-intercept, or sorry, yeah, my x-intercept was at 4, so right there. And my y-intercept was at negative 2. And again, all I have to do is just connect and extend to create my line. Good? Give me thumbs. How we doing? Okay. Okay, a little more practice here. This time I want the equation of the vertical line. Which axis does it cut? So it's an x equals equation. Everybody show me with your fingers. X equals what? What's x equal there in that equation of that vertical line? 3. Yeah. X equals 3. You got it. Okay, all the x coordinates are 3, aren't they? Okay. Okay, last of the line stuff. It says find the equation of a line having the given slope and containing the given point. Now notice that they're going to want us to type our answer in the simplest form, which is slope-intercept form, right? Y equals mx plus b. That's where we finish, not where we start. I can't start with slope-intercept form because I don't know, I know a slope, but I don't know an intercept. So what's the equation that I'm going to use to start this time? Where am I going to start on this one? Cale, what equation am I going to start with if I'm given just a random point and a slope? Okay, so what is the, I don't care about the name, what's the equation? Y? Yeah, you're right. Y minus, so just in general, y minus y1, right, equals times. That's it. Okay, so that's called, anybody remember what that's called? Okay, it's pretty easy because it's based on the stuff you're feeding to it, right? A point and a slope. It's a point-slope form, okay? How come? Because that's what I know, the coordinates of a point and a slope. Okay, again, what's my point? My point is x1, y1, and what's my slope? My slope is just m, right? So I feed all that stuff into our formula, y minus y1 equals m times the quantity x minus x1, and then I just put it in slope-intercept form by isolating y, right? So everybody tell me, what number am I plugging in for y1? 2. What number am I plugging in for x1? 6. What number am I plugging in for m?
3.
Yeah. and we get y minus 2 equals 3 times the quantity x minus 6. Okay, from here to put this into slope-intercept form, it's always the same two steps. What are they? Distribute the slope and then isolate y, right? So we distribute the 3 and we get y minus 2 equals 3x minus 18. You isolate y by adding 2 to both sides. And we end up with the equation y equals what? 3x minus 16. Negative 18 plus 2 would be minus 16. Okay, good. Good? Okay. Yeah, I realize that. Yeah. Okay, same question, only this time we have to do a little more work, right? So we want to find the equation, write it in slope-intercept form. I'm going to start with the same equation. This time, though, I have 2 points. I only need one to plug into my point-slope form. How am I going to get a slope? Slope formula, yeah. Okay. So let's see. Ella, what's the slope formula? Do you remember? Slope formula. Oh, Ella, do you remember what that is? There you go. y2 minus y1 over x2 minus x1. Good. It doesn't matter which point you pick as point 1 and which one you pick as point 2. You just have to be consistent, right? So what's one way I could subtract here on the top? What do you think? Yes, Vance.
2 plus 14.
Okay, 2, and I'm subtracting negative 14, which is the same as adding. So now we just have to be consistent. So Vance is going right minus left. On the top, got to do the same thing for the x's. So what would have to be on the bottom then? Okay, so that gives us a slope of what? What's on the top? 2 minus negative 14 is 16. 3 minus negative 1 is
4.
16 divided by 4 is
4.
There you go. Which point, you could use either one. Which one might be a little bit easier?
Probably putting it over the negative 1.
I mean, which values do I want to plug in for x1 and y1? The first point or the second? I mean, I would say that looks a little bit easier, doesn't it?
Yeah.
I think so. It doesn't matter. Either one would work, but probably use this guy over here. So I'm plugging 3 in for x, and 2 I'm plugging in for my y value. And you guys already told me that the slope is 4. So I'm plugging that in, right? And then this becomes just like all the other problems. I get y minus 2 equals 4 times the quantity x minus 3. And what are the steps from there? Same, it's like getting kind of boring. Same thing we did last time. What do we do first? Distribute slope, isolate y. Good, so if we distribute the 4, we get y minus 2 equals 4x minus 12. We add 2 to both sides. And we get y by itself equals 4x minus 10. Everybody agree?
Yes.
Okay. All right. And then finally, probably where we'll end up today, let's just look at a couple examples of like graphing transformations. So we'll look at some absolute value functions. So sketch the graph of the function. What's the shape going to be? What's this? Make with your hands. What kind of, like what's an absolute value function look like? Yeah, it looks like a V, doesn't it? So we know we're getting a V shape. All we really have to do here is we just need to know like what are the parameters so we know how to graph this thing. Where are we translating our V? Are we stretching or compressing or reflecting it? All that stuff, right? So okay, so what is the value of A in my function? F of x equals the absolute value of x plus 2. Show me with your fingers. What's the value of A? It is value of A. Okay, is it 0 or 1? Because it's invisible. Now I'll give you a hint. Well, you tell me, is A something that's being multiplied or added? Okay, so if a number is invisible and it's being multiplied, what is it? It's 1. There you go. Good. So A is 1. Okay. What is the value? This is the tricky one. Show me with your fingers. You got to be a little creative here. What's the value of H? Yeah, it's going to be -2, isn't it? Yeah? Right? -2. Okay, and why is it negative? Because it's the opposite. Remember, that's the tricky one. There you go. The reason it's negative is that H, we're asking ourselves, what are we subtracting from X? Well, X minus what is the same as X plus 2? X minus -2, right? So it's always, just remember, it's always the opposite. So H is -2, and what's K? 0, because K is a number that's being added. If it's invisible, an added number is a 0. Okay, so now we got to think what those mean. The fact that A is equal to 1, is it, give me thumbs on this. Is it stretched vertically? No, it's not, right? In order for it to be stretched vertically, A would have to be a number like, give me an example.
1/3.
Like 4 would be one, right? To be stretched vertically would be like 4 or 10 or some number bigger than 1. To be compressed, what would it be? Like 1/3 or 1/2, a fraction less than 1. To be reflected, what would have to be true? Have to be negative. Well, none of those things are true. So this is just a normal looking graph, just a regular V, right? H is equal to -2. What does that mean? Point with your fingers. Which way is it going? It's going left, isn't it? H for horizontal, right? It's going left by 2. And we knew that because anytime we add a number inside the function, it goes left, doesn't it, right? So it goes left 2. K is 0. How far is it going? 0 vertically, so it goes nowhere. So then this is a pretty easy graph. You guys tell me if the only thing that's being done to our normal V-shaped absolute value graph is it's being translated left by 2, A, B, C, or D. Which one is it? It's D. It's D. We got it. Okay, another one. How about this guy? Okay, same kind of deal. You tell me, what's the value for absolute value of X plus 3? What's the value of A? 1. Good. So what's that mean? Is it tweaked? Is it stretched or anything?
No.
Normal. Nothing. It's not being stretched or reflected or anything. H is 0. So what's that mean?
It's not moving left or right.
Good. It's not moving horizontally at all. There's no horizontal translation. What is K? 3. Right? 3. It's that number. It's the number that's added outside. So K is 3. What's that mean?
It means it's moving up.
Up 3. Vertically, it moves positive 3. Okay, so now pick out the graph. Which one does that? C. Right? Okay, that's the graph where the V got moved up by 3. Okay, one more. One more and we're done for today. Okay, hold. Hey, come on now. We got one more. Then we're out of here. So, okay, one more. Focus here. Be creative. What's the value of A? Yes, -1. I like it. So -1. Now, what does that mean?
It means it's the V's going this way.
Yeah, it gets reflected. Good. So -A means it gets reflected. So it's going down. What's H? -1. Good. So that means, point with your fingers. It's going left 1. K is -2. So where's it going? Down 2. Okay, so first, second, third, or fourth? Fourth. There we go. We're done. Okay, so last stuff we didn't cover yesterday. How would I do a problem like this? It asks which of the given ordered pairs satisfy the given inequality. So how would I check? How would I check to see if the ordered pair -5, -3 satisfies that inequality?
Please excuse this interruption. Lanny Hoddle and Orly Grove to room 206. Lanny Hoddle and Orly Grove to room 206.
What would I do?
Substitute the x and the y
Yeah.
numbers.
Same as an equation. I'm just going to plug those numbers, plug the values in of x and y and see if they make the inequality true. That's it, right? Okay, so let's try that. What would we get for the first one here? If I plug -5 into this, I'm going to get, for x, I'm going to get 2 times -5 minus 5 times -3 is greater than or equal to 10. Well, what's that give me? -10 plus, negative times negative is positive, plus 15 is greater than or equal to 10. True or false?
False.
That's false, right? Because that -10 plus 15 is 5. 5 is not greater than or equal to 10. So what's that tell me? No, it's not a solution. Okay? We do this. Does that make sense? We would just do that for each of them. If it makes it true, then yeah, it's a solution. If it doesn't make it true, it's not a solution. Okay? Do we need another example or are we good? Good? Okay. Last issue then is I want to pull up some practice problems on the assignment and just very quickly have you guys remind me how to graph inequalities. Okay, so this stuff, copy. Okay, so raise hands. Now, I want to graph the inequality x is x is less than 4. Okay, everybody see that? X is less than 4. So first of all, remind me about this. If I'm graphing an inequality, what I'm going to create, an inequality, not an absolute value function. If I'm graphing an inequality, right, what do the graphs always end up looking like? I mean, you've got, just in general, you have a boundary line, right? And then what else do you have to include in your graph?
Shade.
You have to shade a half plane. You have a boundary line and a shaded half plane, right? That's what the solution looks like. So it's always what we're going to create. Now for this one, to get the boundary line, you just replace the inequality with an equal sign, right? So this boundary line would just be the line x equals 4, agreed? Show me with your arms. What does x equals 4 look like? It's vertical, good. How do you remember that?
Because it goes up and down. Because the vertical line is the only one that interacts with the...
How come?
Because every point on that graph would be at 4 as its x.
You're right. And our quick way to remember it is, we know that x equals is a vertical line because a vertical line cuts through what? The x-axis, right? So it's an x equals. Okay, good. So then when I go in to graph this thing, I'm going to pick a line, because I have to do my boundary line, solid or dashed.
Dashed.
It's hard to see, but that's just a plain old x is less than 4. So it'd be dashed then, right? So I got to change my line to a dashed. And we already said it's going to be a vertical line that's going to cut through the x-axis at 4, and I just need to pick another vertically aligned point. Okay, good. Now I got to shade this thing. So if I want the x values that are less than 4, which half plane am I going to shade? To the left. There you go. Okay, and we got it. Outstanding. So let's go to the next one. Okay, same kind of thing. Yeah, here, let me fix it. If I do this, I think this works better. There we go. So y is less than or equal to 4. So the boundary line is what? Show me with your arms. Good. Okay, solid or dashed?
Solid.
Solid, because I'm including the equals. It cuts through the x-axis at what value?
0.
No. Y is less than or equal to 4. So the boundary line is y equals 4. 4. Right? So I've got a y-intercept of 4. I need another horizontal point. And if I want the y values that are less than or equal to 4, I'm shading, point with your fingers, above or below? Below. Y is less than the boundary line means I'm shading below. Okay? So there you go. Okay, one more. We'll call her good. Okay, so now we've got the boundary line, we got the inequality. Y is less than or equal to negative 1/2 x plus 3. So my boundary line is solid or dashed?
Solid.
Solid, good. Now, how am I going to graph this thing? Raise hands. Where do I start? Where do I start? Somebody new. Where do I start when I graph this line? Yes? Good. Exactly. Positive 3 on the y-axis. That's my y-intercept. Perfect. Okay, how do I use a slope triangle to get to a second point? Raise hands. Somebody new. How am I going to do this? Yes, go ahead. Peyton, you got it. So the slope is negative 1/2. So what am I going to do then? And to the right 2, right? We always go to the right, don't we? Because if it's a negative slope, negative 1/2 means that the negative goes on top. The rise is negative 1, the run is always positive. Okay, so we always go to the right with our run. We rise negative 1, we run 4. No, we run 2. What am I saying? We run 2. Okay, and there's my boundary line. Now I want the y values that are less than or equal to my boundary line. So point how I'm shading. Below. Very good. There we go. You guys got this. Okay? Have at it. You can work.